Okay, so now let's head back into the work, into what we were previously talking about. So we've talked about continuity, and we'll need to talk about integration. But before I talk about that, we need to talk about differentiation. So let's just keep it on the reals for now. Just for now. We'll go more difficult. But let's just review a few terms. Most of this you should know from calculus. If you have not taken calculus, you should not be watching these lectures. Even though calculus is very important. Everyone should know calculus. So, remember that if limit as x approaches x naught of f of x minus f of x naught of x minus x naught exists, then we call this number, then the derivative exists. And we call it the usual notation, f prime at x naught. So, one thing you should know, this you should just burn butter proof. You should know that the derivative, that if it's a function, is differentiable. Oh yes, this is also differentiable. If it's differentiable at any points, at all points within an interval, it's differentiable on an interval. So, a function, if it's differentiable, it implies continuity. So, remember we said that a function is continuous if for any x naught, limit of x goes to x naught of f of x equals f of x naught. Now, we define this. But, so now let's see. Now let's try to manipulate this to show that differentiable functions are continuous. Excuse me. This guy equals. And this is what you learn from math that you don't learn from engineering. Well, maybe you do, but what is very important? Biggest secret of the universe. Number 1. You can always add 0. Adding 0 is a big secret of the universe. This guy over here, it's 0. Big secret of the universe, number 2. You can always multiply by 1. Trust me, you may think this is trivial, but it is not trivial. It is so important. Let's just put both of those two in a big thing called secret of the universe, number 1. Multiplying by 1 and adding 0. Very important. There's many other secrets of the universe. For example, the Fourier transform. Big secret. Every signal can be seen in the frequency domain and the time domain. And there's dualities between the two. But that is left to Engineering Ninja, who will be doing lectures very soon. But Math Ninja just has to get better at this. And then Engineering Ninja will also do his thing. So, multiply by 1, big secret of the universe. What does this look like? This guy over here. That's the derivative. This guy. So this guy is f prime. The limit of a constant is the constant itself. So it's f prime x minus x naught. But this guy goes to 0. Times 0 plus f of x naught equals f of x naught. So we are done. Very easy. You can do this in 10 steps. You can do this in your sleep. So there's many theorems that you should know from calculus about differentiability. You should know the chain rule, the rule with the composition of functions. You should know adding differentiable functions, differentiate each. You should know the quotient rule. You should know all these things. I'm not going to read the rest because they're just straight through definition proofs you should need to know. Also, there's, for example, derivative, the maximum that for a differentiable function, there's going to be there's at the max, the derivative at the max is going to equal 0, which because the increasing on one side and decreasing on the other, you move it, it's going to equal 0. And also, direct result of this is Rolle's theorem. I'm going to write this down because not many people remember Rolle's theorem. And also, it's very important. Rolle's theorem. So you have f of x, f differentiable. And f, okay, and you have an open interval, you have a closed interval. Closed on AB. Then you say if f of A equals f of B equals 0. So let's see. Is it open? Oh. I guess it's an open interval. I'm sorry. Open interval. Mathematicians make mistakes. Yeah. I never remember this. Let's see. Yeah. Then there exists a C such that f prime of C equals 0. But you also need the assumption that AB. Yeah, you need that. I'm thinking about the intermediate value theorem. Intermediate value theorem, you need the function to be, you need the interval to be connected. Yeah, I mean you need the space, the domain to be connected. But the intervals we know they're connected, so we don't have to care. So this, the reason why this is true, the direct result of the max value theorem. So we know that if one point 0 and the other point is 0, because it's differentiable, it's got to be continuous. So this guy is 0. If it's the trivial function, meaning all zeros, pick any one, and there's going to exist a C such that it's going to be equal to 0. But remember, when you do a function like this, because it's continuous, every continuous function has a max and a min. So because of that, it's going to have a derivative equal to 0 at the max and mins. And there, we just Rolle's theorem. But I'm not going to bother writing anything rigorous down because it's straightforward. You should know this from calculus if you don't. But there are many results which are important because of Rolle's theorem. So for example, you should know the mean value theorem.